Good morning to all. I'm Silvia Rota, and I will present my research activity of this year. My tutor is Professor Sonia Bergamaschi, and my co-tutor is Francesco Guerra. And my research activity is based on keyword search over structured data sources. This is a brief intuition of the motivation. As you probably know, we already have a keyword search engine for searching on the web, and they are very useful tools because they simplify the search. You just need to put on some keywords and you can search what you want. They are very simply user-friendly. So it would be nice to have a similar tool for searching over structured data sources, for instance, databases or RDF, where today you have to search through SQL language or SparkQL, and a normal user can't do that. You need to have to be a skilled user and to know these languages in order to interrogate these data sources. Nowadays, there are already state-of-the-art techniques for do keyword search over structured data sources, but they use a brute force approach, meaning that they rely on indexes over the data source. They assess the content, index the content, and then you can search the keywords because they are indexed. So is a traditional information retrieval technique. And of course, to do that, they assume that the content is available and remains stable, or at least updates are notified, or otherwise the index, if the index is not updated, you can't find the keywords anymore. However, in many contexts, this is not sufficient. For instance, in the deep web, there are many structured data sources which cannot be indexed, and they change frequently over time. I can make simple example like a flight company website where they schedule flights. It changes frequently, or like eBay or other e-commerce sites. They change frequently their content, so it's not very easy to index such sources, or any kind of blog or social network has these characteristics. So we need a different approach, and we will try to apply a semantic approach to these sources. In our approach, we exploited the semantic that is expressed in the scheme of the data source. Since they are structured data source, they publish or they have a schema that represents the structure of the data source, and we can extract information from that. And moreover, we want to use machine learning techniques to enhance the performance of our system in retrieving the results. And of course, our hypothesis is that the source content is unknown, or it can vary dynamically during time, and we do not assume to be able to access it a priori like other techniques. And this work is in the context of the project Searching a Needle in Amounts of Data, that is funded by the Fondazione Cassa di Risparmio di Modena. Okay, here we have a brief a scheme of the tool architecture that has been implemented. This is a functional schema, so you can see how the query is processed. We have a keyword query made by the user. The query is we have a matcher as the first component who associate the keywords in the query to source elements in the schema. And then we generate a query in the native data source language, and we query the data source and retrieve the results and the results are given to the users. Actually, I'm working on the first component, which is highlighted in red. I mean, here is not so red. I mean, the colors are not. It's the first component that is in charge of matching keywords with data source elements. And this is a brief overview of the techniques that I'm utilizing to do this. First of all, I'm using a hidden Markov model approach. And I use hidden Markov model to model the data source structure. And then I implemented a generalized version of the Viterbi algorithm that allows us to match keywords with database elements and to find the best of kappa. And the algorithm guarantees that the answers it found are really the best of kappa answers. And we use also a modified version of this algorithm, which is a link analysis algorithm, and we use it to estimate the relevance of different parts of the data structures while searching some keywords. We also implemented a prototype, a software that with the techniques I mentioned. And the prototype has shown promising performance in our test scenarios. We are going to test it also on different scenarios. And also, we're currently investigating a learning algorithm to train the model. And also, another possible extension regards querying different types of structured data sources, such as RDF, because right now the approach works on databases, but we hope it will not take long to extend the approach. Thanks for your attention. This is the end of the